Boy, oh boy, aren't those supply chain issues for real. To make up for our absence, we're giving away not one, not even 10, but 100 STMicroelectronics Nucleo L4A 6ZG development boards. But that's only part of what's up for grab on this episode. So, without further ado, welcome to DevKit Weekly, where this week we're reviewing and raffling, kinda, the BK software IP from Intrinsic IDE. So let's get back into the swing of things by starting off with something tangible. This here is a Nucleo L4A 6ZG development board from STMicroelectronics, which is based on a 32-bit Arm Cortex-M4 CPU core that runs at 80 MHz. And, importantly, it has 1 MB of flash memory and 320 kilobytes of SRAM. More on that in a minute. A quick glance at the board shows it includes ST Zio connectors, here, that provide access to the Arduino Uno V3 Shield ecosystem for prototyping and application expansion, and these ST morpho extension pin headers for accessing the STM32 MCU's IOs. The kit has a couple of USB on-the-go ports for power and connecting to a host, and aside from the USB, programming and debug can be conducted using an ST-Link V2-1 debugger and programmer. The board's also compatible with the SW4STM32 and STM32CubeL4 embedded software environments, as well as toolchains like IAR's embedded Workbench for Arm, Keil MDK-Arm, GCC-based IDEs, and Arm mbed online. You can develop on the Nucleo L4A 6ZG so long as you have a machine that runs Windows 7, 8, or 10, or 64-bit Linux, or macOS. But let's go back to the memory for a second. Who knew it could be so interesting that it warrants 2 mentions in the same DevKit Weekly? Well, here's why. The reason we're reviewing this particular kit is that, well, alongside basically any other kit with an SRAM-based microcontroller, it works with Intrinsic IDE's BK software IP. For those of you who are unfamiliar with Intrinsic IDE, the company is a leader in embedded system security IP, most notably in the form of SRAM physical unclonable function hardware IP. The SRAM PUF is an incredibly unique security technology that's being adopted more and more as a hardware root of trust. Because roots of trust protect so much sensitive data, their fundamental requirements are that they be immutable and that they're able to preserve the unique identity and authenticity of a device down to its most basic levels. So rather than requiring cryptographic keys to be injected into a device during silicon fabrication, SRAM PUFs take advantage of sub-micron process variations in the SRAM transistors themselves that give off a unique signature when the transistors are powered on. This unique signature can be used to generate truly unclonable functions that provide the basis for root of trust root keys and subsequent private and public keys that protect stored data, communicate securely with the outside world, and so on. It filters out noise from the inherently entropic uninitialized SRAM signal and uses it to create intrinsic PUF keys that are never actually stored, just reconstructed on demand later using that SRAM's unique fingerprint. These keys can act as the root key for a root of trust, which itself can be subsequently used in the creation of public and private key pairs. Different configurations of BK software IP also support a scalable number of out-of-the-box cryptographic functions that developers can access from host software via APIs. These functions include randomness and key generation functions, symmetric key crypto functions, elliptic curve crypto functions, and other more basic and more advanced functions. All BK software IP configurations, Safe, Plus, and Pro, are available in key strengths of 128 or 256 bits. They generate SRAM PUFs between 0.7 and 1 kilobyte in size. They take up an additional 7 to 26 kilobytes of code, in addition to complying with a number of industry standards like Common Criteria EAL6+, Automotive SPICE Level 1, and others. But the most significant feature of the software solution is that it can be used on any MCU or microprocessor, new or legacy, in development or in the field, on any process node between 5 nanometers and 350 nanometers. The ability to implement a robust HSM-grade root of trust through software in new devices or those already deployed in the field is a game changer for IoT device security everywhere. And if you're looking to change the game yourself, don't we have the stack for you? Engineers can download a free trial of BK Software IP, complete with documentation, examples, and demos. And as an added bonus, qualified engineers who complete the software download process will receive one of 100 Nucleo L4A6ZG development boards for absolutely free. Zero, zilch, nada, yet. But because we missed you, we're also going to help you get on your own way to securing the next, or maybe even the current, generation of IoT devices. On May 18th, I'll be moderating an Embedded Toolbox Live webcast in which Intrinsic ID engineers will walk you through how to use BK Software IP to create a unique device identity, securely store multiple keys on or off chip, provision a device with a certificate, and verify the device's authenticity with a challenge response protocol. And all of that's before answering any of your questions on security right there on the spot. To sign up for free, you're going to want to go to www.bigmarker.com/embedded-computing-democratizing-silicon-roots. You know what? Just click the link in the description below. Whew, that was a lot, but we had a lot of time to make up and a lot of ground to cover. But it's all going to be worth it if we set you on the right path to creating more secure IoT devices, which, thanks to solutions like BK Software IP and this ST Nucleo board, is getting easier than ever, and cheaper too. Good luck in this week's raffle, and we'll see you in our May 18th webinar and next week on DevKit Weekly.